Well, good morning, everybody. And let's take a look at your notes here. For up at the top, this you should change. So that says 7.1.3. So we're going to continue our work with factoring. We're going to take a look at factoring out a common factor and look at how do we factor trinomials where that leading coefficient doesn't start with 1. So let's start off with the common factor. Okay? So the common factor, basically, and there's a little apostrophe missing here. My English department people would be happy with me if I didn't correct that. Common factor, factoring out common factors, is the highest number and or variable that goes into all of the different terms of the polynomial. In your notes here, cross out difference of perfect squares. We actually talked about that yesterday. So we don't even have to take a look at that. So what I mean by this is when you have different polynomials, sometimes you can factor out what they have in common. So when I look at this 5x squared plus 15x, I ask myself, what number goes into both 5 and 15? Think of the number that goes into it, not what's left over, because a lot of people will say 3, because 5 goes into 15 3 times. But the number we're actually thinking about is that number 5. We're going to put that on the outside. They both have, this has 2 x's versus 1, so that means they share 1x. So I'm going to put 5x outside the parentheses. So then I have to think about, if I took the 5 away and I took one of these x's away, what do I have left? I have just x. If I multiply these two together, they should give me 5x squared, and they do. Same thing here. I say, oh, well, how many 5's go into 15? 3. If I pull out the x, it's gone. So notice how 5x times 3 is 15x. You've completely factored that one correctly. So like this next one here. Same process. If I look at this, they are all even numbers, so they all have a factor of 2. They all at least have one x in them, so I can pull out an x. So when I do, I'm left with just x squared. 2 goes into 10 5 times. I pulled out an x, so an x. It goes from x squared to x. 2 goes into 12 6 times, and I pulled that x away, and I'm done. Now, here's the fun part about it is we might be able to factor it further. So what happens is I can look at this and say, oh, what are factors of 6 that add up to 5? Well, that's just simply 2 and 3. So I can factor this as x plus 2, x plus 3. So there will be occasional problem where you can take it even a step further. All right, so let's do some practice problems where we're factoring out the greatest common factor. Okay. So let's take a look at the first one, 21 and 15. Well, they both share a 3. They don't share any x's because 15 doesn't have an x. So I'm left with just 7x plus 5. I can do a quick check. 3 times 7x is 21x. 3 times 5 is 15. I know my answer is correct. All right, let's take a look at the next one. 15 minus 20x. They share a 5. 5 goes into 15 3 times. 5 goes into minus 20, minus 4. And I have the x. Again, you can distribute and check. 5 times 3 is 15. 5 times negative 4x minus 20x. Just like that. 2 examples done. All right, we'll slide up a little bit. Ooh, x to the 5th minus 5x to the 3rd. 5 x's, or here's x to the 5th, x to the 3rd shares x cubed. So they have basically 3 x's multiplied together in common. So that leaves me x squared. I pulled out all the x's, minus 5. Ooh, perfect square, but since 5 is not a perfect square, I can't factor it any farther. I gotta kind of check those difference of perfect squares. So those can sneak up on you. All right, next one, 4 and 12. Well, 4 goes into both 4 and 12. Whoops. I forgot to talk about the x's, and they also share x in common. So what do I got left? I just have x, and 4 goes into 12 minus 3. I pulled out the x, and I'm done. I can quick check. 4x times x, 4x squared. 4x times minus 3, minus 12x. All right, ooh, this one kind of looks like a twofer here. Let's see what happens. I can, speaking of 2, factor out a 2 first. So I just have x squared minus 10x plus 16. I knew not to do any x's because the last term didn't have any x's. Ooh, let's think about this. Factors of 16 that add to negative 10. I think that's minus 2 and minus 8. So I have 2 x minus 2's, x minus 8's. And got that one done. All right, let's take a look at the next one here. Ooh, they share, looks like they have a 3 in common. They look like they all have an x. So 3x is on the outside. I have x squared. 3 goes into 21/7. Reducing by x. 3 goes into 36 12 times. Oh, it's the x squared plus 7x plus 12. We've seen this one several times, haven't we? Factors of 12 that add up to 7. 3 and 4. So I have 3x. So I have x plus 3, x plus 4. Could you write it the other way, 4 and 3? Absolutely. Got that one done. All right, I look at this one. They share a 4. So I have x squared and minus 16. Ooh, difference of perfect squares. So I have x plus 4, x minus 4. And we got that one done. All right, let's look at this one, last one here on this page. Okay. Even though I know these are difference of perfect squares, they do have a number in common, so you should factor out the 4 first. 9x squared minus 25. They still remain 2 perfect squares. So I have 3x, 3x, square root of 25 is 5, minus 5, and you got the answer. All right, just like that, we talked about factoring common factor. All right, the second part of our lesson today is looking at how do we do factoring, okay, to factor trinomials when the leading coefficient is not 1. So what I'm saying is problems like, how do we do a problem like this? 6x squared minus 19x plus 10. Because we're not going to have factors of 10 that add up to negative 19. It won't necessarily work that way. But there is a trick, and we're going to do this thing, solve them by factoring by grouping. In order, and we're still going to do this crisscross method. How the crisscross method actually works, and it kind of takes you step by step. We identify these values, A, B, and C. So you can see that A is 6, B is negative 19, and C is 10. It says here multiply A and C together. So when you multiply those together, 6 times 10, that's what you're going to write down here. So now it has to multiply to 60, but now add to negative 19. So, as it says here, find 2 numbers that multiply to give you 60 and add up to the B value are negative 19. So what's nice here is they've done it here for you. They found the 2 factors, negative 4, negative 15. So this gets a little more challenging. So then what you do is you take this minus 19x and you break it up into 2 terms. You write it as minus 4x and minus 15. So what happens here is now you have 1, 2, 3, 4 terms. So what you're doing is you're breaking that minus 19 to minus 4x and minus 15x. You bring down the first term and bring down the last term on both sides. So then what you're going to do is you're going to factor out common factors, but you're going to group it by the first 2 terms. So you can see how I put the first 2 terms in parentheses and the last 2 terms in parentheses. And notice how I did the sign with it. So now I look at what do these 2 terms here have in common. They share a 2 and a x. I apologize, this is kind of interesting that this says 6x. Oh yeah, I'm sorry that this has a squared here, so that's just a little bit of a typo here. I apologize. There's a little typo in this problem. So you factor out a 2 and an x. Okay, so when you do, that leaves you 3x and a minus 2. When you look at what these 2 have in common, they have a minus 5. So I always want to put the minus outside it. So minus 5 goes into 15x 3 times. Minus 5 goes into positive 10 minus 2 times. When you do this process, these 2 terms in the parentheses must be the same in order for this to work. So what happens is you take the outside terms, 2x and minus 5. They become, I'm going to kind of rewrite this. I like to write that as my first set because I have 2x minus 5 sets of 3x minus 2's. Honestly, you can flip them around, but I prefer to have them written that particular way. It's like saying, if you didn't follow that, if I was adding 3x and 4x together, how you're doing that mathematically is you're saying, oh, 3 plus 4 times x. You can actually combine like terms and get 7x. Here you're saying 2x sets of this, and I'm subtracting 5 of those. So I'm just combining them just like I did here, but I can't simplify them into a single term. All right, let's run through a couple example problems to show you how you go through this a little bit easier. Because I think when you see a few more examples, it makes life a little bit easier. So the first thing I start to do is I multiply my a and c. I get 15. What are factors of 15? That add up to 8. What's nice about this is it happens to be 5 and 3. So what I can do is rewrite 8x as 5x plus 3x. So then what I do is pull down the first term, 5x squared, and pull down the last term, plus 3. All right, now I have 4 terms. So I'll factor this by grouping. Group the first 2 together. They share a 5 and an x. So what do I have left? Just an x. What do I have left here? If I pull everything out, I'm still left with a 1. It's 5x. It's got to be 5x times something gives me 5x. Well, it's 5x times 1. Group these together. They share just a 3 in common. What do they have left? X, and 3 goes into 3 one time. Notice how these are exactly the same. So I have 5x plus 3 sets of x plus 1's. Now here's the beautiful thing. I can actually check this by FOILing. 5x times x is 5x squared. I have 3x, and 5x make 8x. 3 times 1 is 3. I know my answer's right. So that's what's beautiful about these problems is you can actually check to see if you got them right at the end. All right, so again, I multiply first and last 2 terms together. Minus 36 has to add up to minus 9. So this is where it becomes a little bit of a guessing game. So I'm looking at 2 factors that differ by 9. 1 and 36, no. 2 and 18, they differ by 16. No. 3 and 12, yeah, they differ by 9. So if I go minus 12 and positive 3, that's good. So now I rewrite this minus 9x as minus 12x plus 3x. So I have 2x squared and minus 18. So I group the first 2 together. So I have 2 and an x. So I'm left with x minus 6's. Group the last 2 together. I have plus 3. I have x minus 6. Notice how they are exactly the same. So I'm left with 2x plus 3 sets of x minus 6's. If I do a quick check, 2x times x, 2x squared. 3 times x is 3x, minus 12x. Notice how those are those values right there. Give me my minus 9x. 3 times negative 6 is minus 18. So hopefully seeing those 2 examples should be enough. So I'm actually going to skip the last 2 examples in the notes as you'll have a couple more practice. And trust me, we'll do a lot more of these later on in the lessons. All right, so you can actually go to your CFU packet. We'll do the CFUs and the assignments.